Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. What's up guys? Welcome back to my YouTube channel. I'm Amirul. So for today's video, I would like to share with you about fundamental of logics, which is mathematics. Although I hate mathematics, but I like money, so I cannot deny it 100%. So let's jump into it. Fundamental of logic. First of all, the picture over here is logic gate, which is some of the application of logic in our daily life. Okay guys, before I start, let me clarify something about logic. What is logic actually? Logic is about we put a reason into a statement. Okay, let's jump into it. So first of all, we need to have premises, and we need to know what is the premises. So for today's video, I want to share with you, but I'm not confident with myself either I'm right or wrong, but you can correct me if I'm wrong in the comment section below. So in order to start, what is logic? We need to know that premises are either true or false. So next, so the first one is about negation. Negation, we have two symbols. The first one is like the tick symbol but upside down, and the second one is the wave like symbol, which is tilde, and both of it is the negation symbol. So how to use negation in logics? For the premises P, I am at my home, and for the premises Q, I am safe. So in order to negate these premises of statement, we need to put the symbol in front of the P and Q premises, and we need to add the word not in the statement. So instead of I am at my home, we negate it into I am not at my home. And the second one is I am not safe. Okay, next. So the truth table for negation is if we put 0, 1 over here and we negate it, 0 turn to 1 and 1 turn to 0. So the second one is about conjunction. Conjunction symbol is like V but upside down, arrow like a rooftop, and what we call this is AND. So how to use conjunction? When we put this P, so the premises become I am at my home and I am safe. We just add the word AND in the middle of the two premises. So this is the truth table of conjunction. If we have P 0101 and Q 0011, so the thing is we only can get a true value if both of the premises is true. So 0, 0 is false, so we got 0. So 1, 0 false, so we got 0. 0, 1 is false, so we got 0. 1, 1 is true, so we got 1. So next one, disjunction. Disjunction is the opposite of the conjunction, which is this, we use the symbol V, rooftop upside down. Is it right? Right, yeah. So the word disjunction is actually or. So how to use or in the logic? So we just do the same thing as conjunction, but we combine it with the word or in the middle of two premises. So the statement become I am at my home or I am safe. So this is the truth table for disjunction. For the P 0101 and Q 0011, we only get a true value if either of the premises is true. So if 0, 0, we get false, and 1, 0 got true, 0, 1 we got true, and 1, 1 we got true. So let's proceed to the next one. Fundamental of logics. To the next, second slide. The same premises. The fourth one is implication. Lorry. We use the symbol arrow to the right. Like this. Okay, so P, we said it like P implies Q. We can, for our understanding, we can say P arrow Q, P to Q, but the correct pronunciation for this is P implies Q, the word for implication. So we use if and then. For example, how to use this thing is we put if in front of the first premises and then in front of the second premises. The example for this is if I am at my home, then I am safe. So for the truth table, with the value P 0101 and Q 0011, sorry, it's my phone. So for implication, truth table, we can get true for all of it, but the only false that we can get is when the first premises is true and the second premises is false. So let's look into the slide. P0 Q0 equal to P implies Q. We got 1. P1 and Q0. Since the first one is 1 is true and the second one is false, so we got P implies Q is false, and the next two is true, since the only false is the first one is true and the second one is false. For the fifth one, biconditional. Biconditional is what? We use the symbol double arrow to the right, to the left, like that. And the word for it is if and only if. Biconditional, we use the arrow symbol of to right and left, but the combined one. So actually you have one symbol, but we can like spread the statement. I don't know, but we can spread it to become P implies Q conjunction, or P implies Q and Q implies P. Look at the slide. So the example for this is, I am at my home if and only if I am safe. So as you can see, we put the sentence of if and only if in the middle of two premises to make this statement become biconditional. So for the truth table, it can only be true if both of the premises is the same. Either both is false or both is true. But other than that, we will get false. So look at the slide. P0 Q0, we got 1. But if we want to make it clear, if you cannot imagine how logic is 0 0 equal 1, we can spread the statement into two statements. P implies Q and Q implies P. So if P and Q is 0 0 0, P implies Q is 1, Q implies P is 1. So we got P biconditional, Q is 1. And the next one, if P is 1 and Q is 0, P implies Q is 0. Since P, the first premises is true and the second premises, which is Q, is false, we got false for implication. So the next one is Q implies P. We take the Q equals 0 equal false implies P equals 1, which is true. So we have P implies Q equals 0, Q implies P equal 1. So we got P biconditional Q is 0. Because why? Because P implies Q, we have 0, and Q implies P is we got 1. So we don't get the both true value. So the biconditional is false. So that it is the same thing as the next one. So the sixth is about exclusive OR. Exclusive OR with symbol V and underscore under it, like this. Strawman. And the word that we use is either or. So how to use the word? Okay, before that, only one can be true, but not both are true, which is a contradiction of biconditional. Biconditionally, both of it is true, but exclusive OR is only one is true and the other is false. Only one can be true, but not both are true. So it is XOR. The example is either I am at my home or I am safe. So let's jump into it. P0101, the first one is P0, and Q0011, and the first one is 0. We have both are false. It says that only one can be true but not both, and also not both are false. I forgot to put it there, but I'm explaining to you right now. So as you can understand, 0 0 equal to 0, and P value 1 and Q value 0 equal to 1, since only one can be true, which is P, and Q is false. So you proceed to the third one, which is iPhone. Okay, so this is about laws of logic. Oh my god, I forgot to explain to you about the definition at the first of the video, but it's okay, we will do it the last of the video. So the first law of logic that usually use fundamental of logic is commutative rules, which is P and Q equivalent to Q and P. The same goes if P or R or Q equivalent to Q or P. So the next one is associative rule, which is P and column Q and R column is equivalent to P and Q column and R. So it applies the same thing if, for the and so for the conjunction. And the next one is double negation. Double negation is you can see the symbol of negation twice in front of the premises. So not P is equivalent to P, which is the two of it negate each other. The fourth one is De Morgan's law, which is you see in front of the outside of the column, not column P and Q column, we actually distribute the knot into the, let me make a pointer pen, plug it, distribute into P, into it symbol, and into Q. So what do we get for its equivalent? Since we not the P, so we get the equivalent of not P. And next we not the N, we got the or. And since the conjunction is contradict to disjunction, since we not the conjunction, we got the disjunction. And the same thing apply, not Q equal to not Q. So same thing, this time it is motorcycle, don't know what to do. PKP also racing lah. Disjunction is the same thing, apply with the same thing as what is above. So let's do an exercise, which is a simple one. If it is hard one for myself, I cannot understand the problem. So we do the simple one only. Okay, first of all, the question is about use law of logic to reduce, negate column P, negate column P and Q column implies R. This time mosquito come to me pula. It's okay, let's continue. First thing that we need to know is that this thing is actually P and it implies R. As you can see, this is what we call a statement. Maybe we can refer to something similar. Since we have P implies R over here, we actually can change the implication symbol or the arrow into something like this, which is P implies Q is equivalent to negate P disjunction Q, negate P or Q. This thing is what we call an equivalent lah. You need to do a lot of exercises and you can automatically remember it. And first time I also always forgot this thing, and when it come to doing test, exam or anything exercise without I'm looking at the notes, I also forget again. Don't know it's hard to remember this thing. Need to repeat like hafal Quran. So first step to reduce the law of logic, you need to change the implication symbol into the equivalent of it. So this is the definition, the same thing as the question, but we have changed the symbol. Okay, we have changed this one. If you cannot see, okay, we have changed the symbol, and we have also include not in front of the symbol, in front of P. So the second step is we apply the De Morgan's law, which is we distribute. I use another color of pen, red cannot for lecture only. Okay, now we apply the De Morgan's law, which is we distribute the negation into what is inside the column. We distribute it to the R premises. So we get two negate symbol, and we change the disjunction symbol into conjunction symbol, and we put negate in front of R premises. So this is De Morgan's law. So the next step is we do the double negation. So this is the double negation that we apply here. So since the double negation, if two negate, premises become itself. So double negation P, double negation column P and Q we got P and Q only. If you want to put the column, you can still do it, but I have removed it. So this is the reduced form of the statement above. So the final one is double negation. So this is the last slide. This should be at the first slide, but I forgot that I have this kind of slide. I put it at the back of the slide. So never mind, let's get into it. So the definition of fundamental of logic is an argument is a sequence of declarative sentences, one of which is intended as a conclusion, like I said before, reason statement to achieve conclusion. So the next one is the remaining sentences, the premises are intended to prove or at least provide some evidence for the conclusion. See, he want to prove or provide evidence, which is the reason. For the reason, we got the conclusion. Alright, so that's mark the end of my video today, and the references I took is from my textbook and some textbook really thick from online. So if you like this video, don't forget to hit the like button and subscribe to my channel if you want a content like this again in the future. And don't forget to share it to your friend, family and anyone you know, because spreading knowledge is also kind of charity, you know. Thank you for watching. This is Amirul, sign out.